Imagine that you're lying on the beach, feeling the sun's warmth beat down against you. But how is the sun born? And how will it die? Every star, including the sun, is formed in large clouds of gas called molecular clouds or planetary nebula. Gravity pulls this gas together to create clumps, and these clumps gain more mass. Because of that, gravity causes them to collapse in on themselves, forming a protostar. And as gravity squeezes the protostar, hydrogen in the star's core becomes helium. This process is called nuclear fusion, and the energy produced by this process pushes back against gravity, making the star bigger. Stars that are doing this process at a steady rate are called main sequence stars. This stage is the longest of a star's life. A star's lifespan is determined by its mass. A lower mass star burns for longer and doesn't have to burn as much fuel to keep itself from being crushed by gravity. And these stars can burn for trillions of years. On the other hand, a high mass star has to burn more hydrogen to push back against gravity, causing it to live for only a few million years. When a star runs out of fuel and has only helium left, fusion stops in the core. This causes gravity to push harder against the star, making the helium fuse into carbon, and this increased temperature caused by this reaction causes the star to puff up into a red giant. What happens next is dependent on the star's mass. In a lower mass star, the stellar winds will blow away the outer layers of the star, resulting in a planetary nebula. And that will be the birthplace of a new star, and that will leave behind the dense cooling core called a white dwarf. But a high mass star behaves differently. Because the star has more mass, there is more pressure on the star's core, causing carbon to convert into heavier elements like oxygen, neon, and in the heaviest stars, silicon and iron. Eventually, the star can no longer sustain the heat and pressure to continue to fuse elements, causing the stars to collapse in on itself, triggering a supernova. And instead of a white dwarf, the star will either become a black hole or a neutron star, depending on the mass. And a bonus fun fact is that our sun is actually a third-generation star, and we know this because of a process called spectroscopy. It works by shining starlight through a prism and seeing what colors from the straight spectrum are missing. The missing colors are caused by atoms absorbing the wavelengths as the light exits the star's atmosphere. Lines caused by missing wavelengths are called absorption lines. This lets us know what elements are present in a star's atmosphere. When we analyze the sun's light this way, we can see that it contains hydrogen and helium as expected, but we can also see that about 2% of the sun's mass is made up of oxygen, carbon, nitrogen, neon, silicon, and iron, the very elements that are created during a star's death. Due to the amount of these elements, we can conclude that the sun is at least a third-generation star, because a first or second generation would have significantly less of these elements. To review, stars are formed when planetary nebulae collapse in on themselves and create a star that fuses hydrogen to create helium. Then, when a star dies, the outer layers either expel from the star to create a nebula, or they explode in a supernova, and the leftover core is either it becomes a white dwarf, a neutron star, or a black hole, depending on the mass. Also, the sun is a third-generation star, and we learned this through spectroscopy. So the next time you bask in the sun's rays, just think of what it took to be able to feel that.